Hello, welcome back. So, one last thing, this preconditions. What do we mean by that? In simple terms, it is nothing but validating inputs. So, in certain cases, I think in our earlier case, is prime, we didn't have much to check against. Okay. So, any number, any unsigned number could have been passed, and there is a logic to check that number whether it is prime or not. And we had done that. So, any number will work here. But now we have another function called as prime numbers in a range. Right? Range in the sense you should supply the start and end values of that range. In that range, inclusive in the sense we will consider both start and end as well as possible candidates. If they are primes, they will be included in the array that we are going to return. So, in this requirement, there are certain things, certain validations we should do. Okay, what are those validations? Obviously, the range should be valid. For example, in this, look at that, right? So this range 0 and 2, it is a valid range. 2 and 7 is also valid, but 7 and 2 is not valid. It is an invalid range. 0 and 1, valid range. 8 and 10, valid range, right? So, we should check whether the range passed is correct. Should adhere. So, what are the preconditions? They are all preconditions. Okay, here. So, the range must be valid. So, this becomes a precondition. So, we need to check if end is less than start, then we will bail out. We will say, hey, this is invalid. So, how do we indicate that? This is one precondition we checked, right? Basically validating the inputs. So, what is another condition that we need to check? This is C language, so there is no an explicit way to identify the length of an array, okay? So, it is very difficult to identify that. So, for that, we should also have a mechanism to pass back how many number of items are there in the array that we are returning. Okay, so we will not get into the details of that, how it is done in C. I will leave it as an exercise. That is, here we are using pointers and all that, but the purpose of all these discussions so far was not to discuss pointers in C, but to understand the assert driven programming and the debugging techniques and all those things. Pointers and all those things, I think we should discuss in a completely different series, but that shouldn't, hinder our exploring of this concept called as preconditions. And this prime count, this has to be passed. Okay, somebody should create a variable in the calling context and pass a pointer and pass the address of that variable, right? That becomes the pointer for us, which we can actually use to pass back the count value, right? That is what we do in C language. That is how we do it in C language, isn't it? Because we want to return multiple things here. We also want to return the array of primes as well as the count of numbers, two things. The only way to do that is not the only way. One nice way to do that is go for this pointer arguments. Okay, so prime count, this also should be defined. Prime count must not be null, right? If it is null, we will not be able to pass back the number of primes found, isn't it? So, this will limit. In that case also, what we do is if prime count null, we will return null. Or do you think we should be returning null? This is actually a real problem, right? If somebody is not passing this, that means that this precondition is not only just a check and, amicably handling the case, just like how we did in the case of an invalid range. In this case, Better yet, what we can do is actually, we can turn it into an assertion itself and say, prime count must not be null. Somebody should not be simply passing null, right? Because it's a pointer, right? I can simply pass null also as an argument. This is a C language. So that shouldn't be null. So if somebody is passing null, I want to actually cry foul and crash the program. Right? So you can use asserts within the function also in depending upon the case that you are actually dealing with. Here, somebody passing this as null is really bad, because without that we cannot proceed only. Even if the range is valid, we cannot proceed because we will not be able to convey back how many items were really found. So in the calling context, they will not be able to, iterate through the passed in array. Okay. Don't worry about those details. What I wanted to convey is that we have to have preconditions. And during these preconditions, if you want to cry foul, you can definitely use asserts. And if you think the application should not run only, you want to halt and show that problem to the user, you can definitely use asserts. And when you create a real production app, asserts might be removed. So always we should have actual checks along with the asserts also, okay? Because in the production, it is possible to configure the build systems to remove the assertions inside the functions, because that is going to cause some performance issues. So in this case, it is also a good idea in found. What if at runtime something really bad happens, right? Who knows, right? A situation might arise. In that case, you can augment that with an actual check also, right? Will not crash, but you will return null, right? All right. So this is preconditions. So ensure in your functions, whenever you implement, think about what the preconditions you expect out of those arguments that you are receiving. Right? If there are those preconditions, you have to handle them. You have to have conditions checked against, and appropriately you should handle them. Okay. One more word about the way we write some comments to the function. Outside of this function here, near to its prototype, you should always explain what the function does, and never ever discuss how the function does, right? Here, for example, now once all these preconditions are met, of course, you will be having a loop, right? Loop through the range, and use call is prime on each number, and if it passes, add it to the result array. For example, right? This is the what part, isn't it? Will you implement the is prime function here? No, you will not, because it is already implemented. Okay. So you will simply call that. Here you will have a for loop, and you will call that to check whether the number is a prime. If it is a prime, you would like to add it to the target array and return it. So that is an implementation detail. And you know what? I have written all the tests here. It is an exercise for you to give an actual implementation for this function. I will leave it as an exercise, right? So this concludes our series of sessions where we got ourselves acquainted with the assert-driven programming, and at the same time we understood the disadvantages of IO-based testing. And at the end, we also explored debugging and understood how do we debug, and what are the prerequisites for the debugger to work correctly, and how to set up the debugger. It could be the low-level debugger or the VS Code itself. How do we configure that? That also we learned. We learned tons of things here. Now it is the time for us to go back, pick up all those favorite functions which we are actually wanting to implement, and instead of IO-based testing, let's switch ourselves to assert-driven programming. Okay. And using that mechanism, let's implement our functions. Let's take advantage of debugger to understand the behavior of the functions when they actually run, right? This will ensure that our exploring of programming becomes very solid, and also at the same time our implementations become very robust, and we will be leaving a living documentation of our functions in the form of test cases. Hope you loved all these sessions. Go back, start using these practices in your day-to-day programming. All the best. Thank you.